Okay, well, thank you everyone for joining us today. We're here to discuss edge computing, AI, and together with Hub Security's very own CRO, David Hochhauser, alongside edge computing and David privacy experts, Malini Bhandaru and Ramya Ravichandar. We'll start our webinar with a brief introduction from our speakers, followed by an introduction from David on today's discussion topic. And afterwards, we'll open up a bit of a deeper discussion on everything related to confidential computing and data privacy, AI, ML applications, and security. As usual, we'll leave about 30 minutes at the end for Q&A. So if you have any questions throughout the discussion, drop them below and we'll get to them at the end. I'm joined now by Malini Bhandaru. Hello, Malini.
Hello, I'm very happy to be here this morning. And do you want me to go ahead and introduce myself?
Yeah, go ahead. You can also turn on your camera if you'd like.
So I'm Malini Bhandaru at VMware. I lead our open source IoT and ML efforts. So it's all open source from my perspective. And this is an amazing point in time because we have ubiquitous cloud computing, so you can process huge volumes of data, storage is cheaper, and we have so much more in the bag right now in terms of security. So as we look at edge computing and AI, this is the perfect time and space. I have a PhD in machine learning, and I have been working in open source for more than 12 years. And prior to that, I did CPU architecture, and I worked at Intel. So that's my journey. Thank you.
Welcome. Yeah, thank you for being here with us today. I'd also like to introduce Ramya Ravichandar. Hello, Ramya. Welcome to today's discussion.
Hello, everyone. Good morning, good evening, or good afternoon. Thank you for having me on here today. So I am from JLL Technologies. I'm the Vice President for Sustainability Product Lines. I've been working in edge computing and IoT and AI for well over a decade now. My focus has been developing products for the industrial sector. So the sectors like manufacturing, energy, oil and gas, mining, smart buildings are all the different verticals that I've played in. I'm truly excited about the momentum we have today in edge computing. There are a lot of technologies which are ahead of their time, and I think edge is one of them that's been around for well over a decade, and I think it's finally getting its time in the limelight. So I'm looking forward to having a very exciting and healthy discussion here today.
Yeah, me too, definitely. And last but not least, introduce David, or David will introduce himself and then the topic. Welcome, David.
Thank you, Shterny. Happy to be here today. Hopefully I'll sound a little clear. I'm getting over a cold, which is the first illness I've had in 2 years, considering how isolated we've been. And by the way, one of the first today is I actually have an in-person event later on as well. And the biggest decision I have is what to even wear. It's been so long. So I assume pajamas is not acceptable going out to these events. So we'll have to figure that out. But anyway, as Shterny said, so I'm Chief Revenue Officer for Hub Security. Our company focuses on, we have tremendous cybersecurity expertise in both, we design our own hardware and software, and we do a lot of focus around securing AI, and in particular on the edge as well. So welcome. I think this will be a fascinating discussion. And let me just take a couple of minutes to kind of explain why we're holding this session. And then we'll keep most of the session actually focused on our experts on AI and the edge and some of the security that surrounds it as well. So first, why did we kind of convene this, for AI? One, to begin with, there's just massive potential around each of these. They're each huge game-changing areas. And if you think of it, the amount of processing power and information that's coming on from these things is exploding. So you have 5G coming in, just bringing data really much faster that's going to be coming into things. You have IoT, which is kind of bringing all of the processing and everything all over the place, ubiquitous. And now you have between cloud and edge computing, literally we'll have computing everywhere. So the challenge when you have all of this information coming in so fast is how to handle it. And AI is really, and machine learning are kind of the underlying technologies that's going to start making sense of all of this. So you really have all of these things coming together. And how does security come to play in this? Well, there's such rapid change in this technology that when we look at it, typically you start patching together and adding other layers of security and things. We think these technologies, and as they come together, are so game-changing that we really need to take completely different approaches to cybersecurity when it comes to them. And we'll get into a little bit more of that later. But just to give you an idea of when we say, hey, these are game-changing and the size of this, so just to put some numbers to that. Edge computing, I've seen IDC estimates saying edge computing is going to be, in 2 years, a $250 billion market. And from AI perspective, it's jumping to over 260 billion in the next few years from really just around 25 billion a couple of years ago. So you see these two massive, really game-changing markets starting to come together and merging. And what you have is you're taking AI and it's actually kind of bringing, with Edge, is bringing all of this data, really generating and managing it and consuming it, making sense of it much closer to where it is. So to make sense of this, we'll divide the discussion up to 3 general categories, but again, the questions can be, all over. There's no limit on exactly where we'll cover. But in general, we'll talk about edge computing for a while, just to understand and explain it, what some of the technology is, what the challenges are. And then we'll spend a lot of time on AI and machine learning, as well as understanding the applications, the use cases, and also the technology and issues around it. And finally, we'll talk about the security that we need to deal with from AI, especially when we're running it particularly on the edge. So hopefully you'll find this really informative and sit back and enjoy. Back to you, Shterny.
Thank you, David. That was a great introduction. So following up on what you said, we'll begin with our first topic, our first discussion topic for today, which is edge computing. And Ramya, I wanted to get from you just maybe a basic definition to start us off. What is edge computing and what are some of its benefits?
Yeah, I think it's such a great and fundamental question, because I think the word edge, just like AI, gets overused so much, right? The way I view the edge computing category is you're bringing the compute to the data, right? It is the closest point to where this data is being generated, to the source of your data streams, right? So if you think about examples, let's say you instrumented your machines with sensors, having a little gateway that has compute to do some kind of intelligent processing would be considered an edge node. And there are tremendous benefits to having edge computing. You touched upon a bit there, David. But I mean, think about latency constraints, especially as we go into the world of IoT with more and more data hitting at us with very high frequencies. Think about video data. It's just massive. And imagine having to move all of the data from your various smart city cameras across to a central node. You just lost the battle to storage right there. And let's not even get into the bandwidth constraints there. So this is where edge computing becomes so interesting, because not only does it help you with issues around latency and bandwidth and storage, but the true value is when you're able to act on the real-time insights that you get, right? It's the decisions that you're able to make. And honestly, I think sometimes the human in the loop they might be the weakest link, right? How fast can you react? And this is where autonomous driving is very interesting and probably a flagship for edge computing, if you think about it. But then as we start looking at edge computing applications in other industries, which we'll touch on later, it becomes obvious that they've just hit the tip of the iceberg in terms of the applications we can go forward with.
Definitely, and I think many of us would agree with that here. Malini, what do you see the edge as exactly? Is it just a single node or a collection of nodes running as an edge cloud? Maybe you can give us some deeper insight.
Before I get to that, I just want to add a few points to what Ramya said on the latency aspect. I have a Ring doorbell, and somebody comes by the door and I get that little beep a few minutes later. And suppose it's me leaving leaving my house. I pretty much reach the end of the street. What kind of security does it feel if it comes like as a notification 4 to 5 minutes later? So you want that intelligence at the edge to process the day and say, hey, this is some unknown person doing something odd, maybe taking away your package. So you want more and more of that intelligence closer to where that data is, like Ramya said. And that puts more power in our hands. And it'll also bring up things that, David will touch upon, because as you have more deeply embedded devices that are not under a lock and key, that have no security guard outside, security becomes more and more imperative that we make it a first-class citizen. But your question about what do I see as the edge? Is it one single compute node? It could be, but that single compute node could die, it could burn, it could be broken. So anything that you have high value for, or you have a lot of risk associated with, you might want more than one. And that's all about high availability, fault tolerance. And to a point that Ramya made, the flagship product will be these autonomous driving cars. You can't afford to have just one computer at that edge. In this case, the car is the edge, saying, okay, I'm going to process LiDAR data, optical data, and drive you safely from point A to point B. At that point, which you could get into a crash or whatever, you might have a cloud. So for me, depending on your application and the cost point of it, the risk associated with it, it could be a large cloud actually. You could have a collection of computers connected together as a cloud inside that vehicle, so that if you have a collision in front, it's still performing, it doesn't become a break. At the very least, you should be able to get to the side of the road and call for help type of stuff. So for me, the edge most likely will be more than one node, and for multiplicity of reasons, because it might be hard to send a vehicle out there and say, hey, go replace this single node, because the cost of it. And you have resiliency for more, and you can say, hey, we've lost one node here through monitoring. Let's go and install another one at the earliest possible time when it's schedulable type of stuff. Thank you.
Thank you. David, anything to add to the edge definition here?
Yeah, sure. It's interesting because I've the people speak to. In one sense, there are so many different definitions, and I think part of that is because it's still a field that's evolving and people look at it differently. I've seen people, and I agree with the other definitions, but I'd say it's also extremely dependent kind of on the use case. And it really varies a lot depending on the different cases. On the most simplistic level, I've look at it sometimes, hey, it's anything that's not in the public cloud is considered the edge. If it's in another data center somewhere, and it's not sitting, typically on Amazon or something, hey, then let's look at it as on the edge. But more specifically, it could be things like even local data centers. An example, talking about, there's been discussions about how do you go ahead and add more better broadband and applications to rural America, across there. And one plan right now is to actually, the local data centers is to add even 100 local data centers in the area so that they can start processing. Plus you have on-site. And as an example, if you take like farms, by the way, believe it or not, there are actually over 2 million farms in the US. And you don't think, that's really, so what? Do we need to secure something like that? But it's the food supply. And those farms now have equipment running AI from John Deere they automate harvesting in the field. They have drones monitoring the fields. And what a lot of them will have is potentially a local data center so they can move that processing closer. But depending how close it may be, they also might have things literally right on the farm, or right in the industrial plant. And so I look at it, and then they may feed things back to the cloud, and it depends on the kinds of application and how much processing and latency you need to do. So that's why in my head, I kind of look at it, if it's not in the central cloud, it's kind of on the edge. And we'll get into more of it, but as you get into the types of use cases, you might see things. It could be a local data center, it could be right on site, it could be right on the device itself. And I think we'll see kind of different situations from there. That's at least, my perspective from what it is.
I'd like to add to David's point. I work with LF Edge in the Linux Foundation, and we define the edge as anywhere out of your main data center. So it can be the near edge, the far edge, the midway edge. And the sizes of these edge clusters or, little clouds can be 1, 2, 3, 4, any number of nodes. And you'll notice edges, like you mentioned, 5G, a telco edge might have some very specialized hardware. So, and your farm edge might have actually more hard box, maybe concrete around it just to protect it from water and rain and sun. But at the farm level, you are considering how much soil moisture is there, what's the kind of sunshine you've been getting, and pests through drones processing it so that commercial crops can be protected and not overwatered and over-fertilized and harvested at the prime moment.
Thank you both, David and Malini. And Malini, I want to follow up with you on that and ask you, what are some other edge distributed solutions that you anticipate are coming in the coming years, at least, are going to be developed, and how the edge will be used to help support some of these solutions?
So maybe even like 15 years ago, we were talking about farm edges just for crops, for high, costly crops like wine, etc., and your grapes. But I think what's being talked about and not yet mainstream enough is your energy systems. As we start talking more and more about renewable energy, it's not just your wind farms that are, pretty expensive. It's the little photovoltaics that you might have on individual homes. You might have batteries at homes. Even your Tesla car or your Leaf car or whatever car, depending on which country you're in, what your manufacturers are, there are batteries in them, and they can actually store energy when it's cheap, when your utility provides it at a lower cost, and they can act as little centers to give back that power when you need in a crunch. Okay, so we're talking about energy collectors and energy storers, and then I can see a future edge application where we're going to negotiate how much it costs to save some energy in your battery, how much it costs to take some energy from somebody's battery. And there's a lot of security issues here, like you don't want anybody to know you're not at home when you're not at home type of thing, because that can make you a burglary target. But also there's a financial aspect about it. Who's ready to share their power at what cost and how much, and how reliable are they? Because you don't want to say, I'm going to be running my data center or my washing machine or my dryer or whatever based on Shterny's battery, because whatever battery goes down, or what if she wants to take a trip and drive her car away? So there will be things that we do in the compute field. I mean, that's the area my company VMware is very active in, and we have something called virtual storage area network, but that's for storage of bits and bytes. But the same concept is applicable to virtual batteries. And along with Stanford University, we've been thinking about this with their power engineers and their computer scientists. How do we make this happen? And it's kind of like a little more real time. There is the financial aspect and security with that, something like a blockchain, but you don't want to be like making it an oil spill type of stuff. So it should be still energy conservative when it wants to verify who's selling what, when, where, why. So I can see smart grids also being part of this space.
Yeah, I'm going to jump in there because I think you brought up a really interesting use case, Malini. As you know, JLL is one of the world's largest commercial real estate companies, right? And we've publicly announced our commitment to net zero goals by 2040, which means a large part of it is around how do you optimize energy usage in the very large commercial real estate properties, right? And so I think edge becomes so fundamental because you're doing real-time transactions. You're making real-time decisions about, how do I do demand energy optimization in my buildings? Am I as operationally efficient as I can be? If you really go down to the details, you're beginning to look at energy waste across large spaces, right? Why is my conference room still getting heating on a weekend and no one's there. So this is where real-time data streams about occupancy, about the buildings, energy management systems, and how all of them fold together into this one intelligent compute that helps you make real-time decisions. And the renewable space is just so fascinating right now. I mean, I think given the momentum that we have today to start addressing climate risk, the number of new solutions that we'll see in the next couple of years, it's going to be exponential. I feel like we have all of the elements that are here, right? IoT, edge, AI, fast computing, security, but it's the use case that's going to drive all of these pieces to kind of glue together and provide those optimal solutions for energy management. But yeah, great use case for the edge.
Yeah, definitely, and I think as the climate crisis, or the pressure from the climate crisis continues to rise politically, I think definitely there will see more focus on green energies and developing IoT technology around usable renewable energy. Ramya, I wanted to ask you, how should one understand the relation between edge and IoT? Because we hear these terms often being used interchangeably. So maybe you can do a bit of a clarification for us.
Yeah, I really look at the trifecta, so to speak, right? There's edge, there's IoT, there's AI, right? And all three pieces often get talked about as enablers of various solutions. Fundamentally, we're looking at edge as being an enabler of the IoT solution in the sense they make them more effective, right? Imagine if you had hundreds of thousands of devices and sensors distributed across your cities, but you're still having to grapple with the situation of being able to read that data, send it out to a central node, and then process. This is where edge kind of levels that playing field, right? It gives you that view into the world of data streams as they're coming in. And then what's unsaid is how much of this data is actually unusable, right? You still have to normalize it. You have to add some context to it. You have to parse through it, make sense of it before you can actually get it to the next stage of processing, whether it's your ML algorithm or just a simple pattern detection program. So the edge is, I think it's a fundamental enabler, but it also helps you start getting more effective with the IoT solution deployment. If you really look at the technology life cycle, I think decades ago, on-prem systems were the thing, right? I mean, you wouldn't go into an oil and gas plant or a manufacturing plant and say, oh, by the way, you guys need to start adopting cloud, and you would get massive pushback. Today, that conversation is very different, right? They've moved on from a very on-prem style system to adopting the cloud journey. But then you're also beginning to see kind of this loop back into the same big cloud players announcing edge solutions or on-prem solutions where they talk about being disconnected from the external public cloud or private cloud. So in some sense, we've come a full circle, right? Security was a key driver for why a lot of these systems were offline. We went to ease of use, accessibility, and just the ability to scale out with cloud. And now we're recognizing security is again a concern. And so maybe we should go back to the drawing board. And it's always, is it old wine in a new bottle situation? But just going back to the question, edge enables IoT, and I think that we've come a full circle in terms of how that manifests across the industries.
Definitely outline some challenges of IoT adoption, but what are some of maybe the other ones and that organizations will be facing down the line, and how does edge computing alleviate them?
Yeah, it's a really interesting journey. A lot of as a company, you don't want to be at the cutting edge of technology, right? You don't want to adopt IoT. You want to make sure you're AI ready. So a lot of decisions are being made at the C-level suite where they're talking about, let's just go be IoT, right? What does that mean, right? So I really look at challenges in three different buckets, right? There's the people, there's process, and then technology. In the people area, you have decisions being made at a different level, but execution is on the field. And there's a huge gap between the understanding of what is expected, right? Go do IoT is very different from the field operator getting the memo about what that means. Like, how does that translate to a very specific prescriptive solution that they would have to go out and deploy? I think that's a big challenge. And once you identify that as a gap, being able to draw out that value map is really important. The second bit is on the process bit, right? I mean, we have the typical IT OT divide in any industry. And David, you'll smile as you think about security from an IT standpoint and security from an OT standpoint, and how there's a clash between these principles. But being able to bridge that gap is huge. Again, just recognizing and having to work through that, I think, is key for the success of any deployment. And the last bit is what I call the technology integration nightmare. I mean, if you just look at buildings in general, you have so many different systems on so many different networks that they've all been implemented over various periods in time, right? You'll have this one building engineer looking at 7 different dashboards. It's similar across industries. You go to manufacturing, process manufacturing floor, you'll have a field operator or the process engineer having to go pull data from 10 different systems just because they were implemented at different points in time. So the integration nightmare is about how do you bring all of those data sets into this one window view? So you're actually making decisions a bit more effectively, right? It's not a pull model, but it's actually having the ability to see the right alerts, the right intelligent recommendations that are subsumed because of all of these data streams. So Edge isn't a silver bullet, right? Don't get me wrong. Just because you go have a gateway installed, suddenly you're not going to solve all of your problems, but it does level the playing field. And once you bring in ML to drive some of the more basic automation when possible, then you start moving to this realm of having a truly scalable solution where the field feels empowered. And that's key. That's key for any solution to scale. You can't just build something in isolation and not have the operator get insight into how to use it.
Great. Thank you so much, Ramya. That was an excellent response. Malini, I wanted to ask you, you work in open source. What, if any, are the edge compute frameworks that you're familiar with? What are the strengths and architectural pros and cons? I mean, I think that's a bit of a broad question, but you can try to focus it.
So for me, it's not going to be just one edge connecting up or a collection of edges connecting up to a cloud. There's going to be a hierarchy of edges. So let's just take Ramya's use case about, watching how a building works. You're collecting sensor data from, say, thermostats, from cameras, from temperature sensors, et cetera, and then saying, there's no occupancy in this room, let me turn it down. Okay, let me turn down the temperature here and have savings. But think at the next level beyond this building. You might have a collection of office buildings or a collection of buildings in a hospital kind of environment, and so on and so forth. And you go higher and higher up to your town, up to your county, state, and so on and so forth. And for me, these are wonderful use cases. We see them, but what's coming behind the scenes is all the technology that's enabling it. So let's say there's some reduction in power consumption somewhere, then you can send an alert or a notification. So in open source, we have now open events and a standard protocol way of how an event is defined, so that anybody who receives an event kind of knows what time it came, where it came from, what it says, and have some notion about how to interpret that message payload. So that's one of the enabling technologies. Then we have today a lot of messaging systems, and they have different ways that they're set up. Some have persistency, some have guaranteed delivery, some have, hey, I'm going to just supply it to any listener, and if it's not there, it's not there, and that's okay. And that might also be very fine with something like an edge application where you're collecting sensor data like temperature readings. It's okay if you miss a few temperature readings. And most of this data is not very, well, let's not use the word earth shaking. That could be from an earthquake tremor sensor. But if your temperature reading is in some range, like, 68 to 70, it's okay. It's accepted. An exception is if it goes 70, 71, 75, and, it's like rising, then there's an issue. So we can have a lot of machine learning kind of things that just say, here's a range, and beyond this range is something to alarm off of. So in open source, now we have multiple edge frameworks. One of them is called EdgeX Foundry. I was personally involved with it. My team and I made contributions to that project, improved its security posture, etc. But there's also other solutions that we recognize now in the cloud native space where you supply a solution as a container. And then the issue becomes, how do I launch these containers, scale these containers? And Kubernetes is a very active project in that space. And typically they were being run in data centers with about anywhere from like a few nodes to 1,000 nodes to 5,000 nodes. So at your edge, you might not have 5,000 nodes, but a lot of the principles still apply. I want to launch this workload, which is as a container. I might want to scale it a bit, and I might want to have all the usual things. And I think David will talk more to it about who's trying to access this edge node, who's trying to update this edge node or cluster, who's trying to modify something there or attack it. All those considerations, identity, access, updates, and software updates at the edge are very, very critical, because you don't want to leave something open over there because somebody had a bug. You want to be able to patch it promptly. So we're having a lot of improvements in this technology space. So you have these edge Kubernetes type solutions like Kubernetes itself. Then there's something called K3S. There's OpenYurt. There's Kube Edge. So a bunch of solutions in this space that we could use.
Thank you, Malini. Ramya, I wanted to move on now to the topic of artificial intelligence and machine learning at the edge. And Ramya, maybe you can start us off by giving us some insight on some of the key use cases that can benefit from the edge.
Yeah, I think we touched on this a lot in our earlier comments, right? We talked about autonomous vehicles. If you really boil it down to first principles, I think fundamentally any mission critical application that can do well with a write back in real time on your real time, right? So that's a primary application for edge computing. But at the same time, video, I think, is going to be a huge driver. We talked about Malini's ring issues. I'm sure they'll take note of it, Malini, after this webinar gets released. But the campus security is huge, right? Anything around video surveillance is going to become really interesting, whether it's perimeter monitoring for industrial warehouses, and even something as simple as in my previous startup, we did work on a use case where we were detecting PPE equipment in construction sites, right? Are you wearing your hard hats, and are you wearing the safety gear, right? This is real-time insights, and you're able to go send out an alert and say, hey, John, you need to gear up. So across the board, I think anywhere where video is key, edge will become a very fundamental piece of the solution. But then elevating this out to smart cities, because I think they really talk to the scale of solutions. Think about when you have different subsystems having to interact with each other, right? It's also about all of the data coming and the machine being able to resolve that through ML. So let's say traffic flow management, right? This is where you would have to interact with sensors, the physical sensors. You have patterns of traffic flow. Maybe you have some video feeds, and you actually have operational data around the traffic light. Maybe external events that are potentially going to happen that will influence the flow of traffic. Using all of this data, what is the best route for your ambulance to get to the hospital, right? You can't get any more real-time than that, and you can't get any more mission critical. It might be a life or death situation for someone. So that's another, I think, great example of how different systems will need to get leveraged, but need to get leveraged in a manner that we can't have any kind of latency in the types of decisions we make. And that decision can keep changing because the environment is so dynamic, right? And that would be a great example of where edge would come and be a shining star. Of course, we're all, when we talk video and we say surveillance, we talk about, facial recognition. I'm not going there. It's very early. I think we'll talk a bit about, where AI can have loopholes and how we can fix that. But just, I think let's get the fundamentals right first. Let's work on the basic use cases where we are seeing true value, and then get into the fancier ones, which solve more of the first world problems.
Yeah, definitely we're seeing solutions on the edge being developed. first in the first world, and then we'll see how we trickle
And
down.
I want to make a comment here about first world problems in autonomous driving, but 5G and cell phones have been something that have made communication possible, keeping people connected so much, even in third world countries and second world countries, from payments to exploring markets. And I just see this as like so awesome all around the world because of all the technology that's come along. But there's a question from Kishore. He's asking, could we have some examples, implementation related context of 5G architectures? Does anyone want to take a shot at that?
And can you just repeat that last thing? It faded out for a sec.
Okay, there's a question from Kishore. He says, could I please have some implementation related context for 5G? So for 5G architectures.
Yeah, I think 5G opens up the bandwidth and the speed with which you can process a lot of these data streams, right? I mean, we were talking about video a lot. I think with 5G, video use cases get a bit more easier to work with. But
I think we need to, Kishore, I mean, if you want, you can maybe put your mic on. When you talk about implementation, what's your question? Are you talking about the hardware that you need at like 5G base stations? Are you talking about technology? Like, do we need real-time processing or near real-time processing? What are you trying to get at? Or are you talking about software radios?
Malini, I don't believe he can use his mic, but if you'd like,
okay.
Clarify.
Please enter your question then in the chat, and then we'll try and answer it.
Right. I mean, just to add to that a little bit, because we're doing some work with some telcos, obviously from a security perspective. But there are two aspects. There's actually, they have RAN software, radio access network, to manage the 5G. Those things themselves, one, those have to be secured, but two, it leaves, there's an approach about running secure processing right at the 5G towers as well. And there are discussions, talking about how do you do that? How do you have a safe and secure means of running all of these AI processes at the actual towers themselves? So one, we're looking at things personally on how to run the software, the infrastructure software that's managing the 5G towers, as well as now how do you put processing for secure processing right at the tower to be able to do it as well. It's actually somewhat similar technology for both. So if that adds to it, and I'm sure the question you have is probably can be interpreted in 100 different ways, but at least, each of us have at least given some perspective, and hopefully that helps answer some of it. And if not, also, by the way, you could send us emails afterwards.
Yeah, so Kishore hasn't entered anything more. He says, I mean, from 5G technology perspective, where in 5G core NR edge can be enacted. So Kishore, 5G, think of them as more present little edge centers. You have them across buildings nowadays, your microwave towers. Like if I look from my rooftop in India, I can see at least maybe like 3, 4, 5G, cell phone towers. With 5G, there will be even more of those. And why? Because at the bandwidth that they are transmitting, the towers have to be closer. And things like rain and moisture and dust can also interfere in this transmission. So you'll see more of these transmission points or base stations. And at the base of the base station or in the box or whatever you think of, you might have very special hardware that has maybe persistent memory, so that you don't have to worry about getting some update from far away and losing it and things like that. So that's faster memory to handle line speeds of 5G data entering. Then we have things like splicing of this 5G spectrum, like you had time division multiplexing, frequency division multiplexing. Here you will do slicing of that network bandwidth so that Ramya's data can go through and David's data can go through and somebody else's, and we can even have slightly wider pathways for some based on what kind of SLA they have. So those are the different things that happen. And at a processor technology level even, and this depends on the kind of timescales you want to address packets at. Now we're talking network packets at line speeds for 5G. You might have some kind of cache allocated, pre-allocated for certain processes that are taking these packets off the fiber optic cable or whatever, so that they have their latencies locked in, very little jitter and so on and so forth. And then multi-tenancy will happen because these little edge clusters for 5G, it's a lot of infrastructure. There is some protection involved. So you want to run multiple people's applications there, and that's what we call multi-tenancy. And you might want to protect a model, a machine learning model. You might want to protect some other software. And there are things like the trusted platform modules. There's things like secure enclaves and so on and so forth to make some of these possible.
Thank you, Malini. David, other than agriculture, we spoke about agriculture, autonomous driving, what are some of the industries or applications for AI at the edge that will have very high or seemingly high critical security requirements?
We've touched on some of them. Others, I'll at least kind of give some examples of just the tons of people that I'm talking to and some of the things that they're working on, currently in areas. I mean, my quick short answer is, hey, if it's worth developing an AI application for, it's likely sufficient enough that you're going to want to protect it. That's kind of the flippant short answer, but everything depends on the degree of effort that you want to put in for security. So the things we're seeing, one is I think we'll see a huge emphasis on critical infrastructure. You've seen, and actually critical infrastructure cuts across almost 14 different industries, but you've seen just lately, right, attacks dealing with supply chains, food supply chains, chemical pipelines, energy pipelines, water supply systems, and they've all been attacked recently, but that infrastructure is critical. And a lot of things that we're doing to automate that and protect it will be AI driven. And we've talked about a little bit, drones. Drones are used for a range of things. Malini talked about it from a perspective of all the things going on, in the food supply chain and farming. They monitor pipelines and stuff remotely. Not to mention, once you get into the military, had discussions enormously what goes on. Drones is a whole separate discussion and level of security that needs to go on from that perspective. So I think we'll see a lot of effort going on in critical infrastructure. Healthcare is an obvious one. I spoke to somebody yesterday. They're doing some automated monitoring of dialysis, and they try to literally, okay, let's see, how can we impact this? Now, all they needed to do was change a few data, a little bit about the data feed, and the dialysis went all of a sudden to change the entire reading to say, okay, it's normal, and change the direction of what happens. And so if you think of personal monitoring of heart devices, dialysis, diabetic stuff, that actually will get people kind of nervous about the things that we're doing to automate that and monitor. So I see a lot of emphasis will potentially go there. The most common one, as well, not the most common, but one classic one is automotive. Everybody thinks about self-driving cars and everything. It always comes up in discussion. As I said, use case dependent. Think about latency. You're driving along and there's a car crash up ahead and you're about to crash. You don't really have enough time to send your data back to a central data system to do processing for 15 minutes and then come back and say, you may want to step on the brake. By then, you're history. So just as examples of discussions along the way. And as I mentioned before, the other thing is protecting kind of the edge itself, actually securing these 5G towers. And the one thing I'll add is I think you'll see them, as Malini said, they need to be far more of them because of the bandwidth issue. But we're seeing them talking to railway stations who lay fiber along them and popping up 5G towers. You'll see a lot of different, I think because of the proliferation and needed for those towers, we're going to see some really interesting places where we'll end up putting some of these things in application. So this list can go on. I have a list of about 200 things. These are some of the ones I've spoken to people recently about, at least. where I see the emphasis going.
For many, the Continental pipeline hack is still really fresh, and also the attack on the big meat processing facility in the U.S. as well, whose name escapes me at the moment. But Malini, I wanted to ask you, maybe, do you see a need for special purpose hardware at the edge, such as FPGAs and GPUs?
This comes back to David's point and to Ramya's point, and everyone, it's all about the application. So FPGAs are not cheap. GPUs are not cheap. So it all depends on the kind of edge you have and what the purpose of that edge is. Suppose you have some content delivery system just for movies or something at an apartment complex or a gated community, or for a university or hospital, you might do something there, especially if it's something like a hospital environment where you might want to process image data. Is there cancer here? Is there some other, you're doing some pathology and want to check for some organisms or something? Then yes, it's a worthwhile consideration to put that special purpose hardware because of the value of that edge and the processing it does. But my little Ring doorbell might not need such a thing. A little Raspberry Pi under $30 might be plenty for it. So it's all your application.
Thanks, Matt. Ramya, what is your advice to someone or an organization that's just starting out on this journey of edge computing?
Yeah, my recommendation is to think about what is the outcome you're driving towards, right? What is the business value that you want to get to, the impact that you want to have on your user base. There are a lot of different technology choices you could make, right? But they should be driven by the end goal that you have in mind. Sometimes the newest and the shiniest object gets our attention, and we tend to build our solutions around those pieces, and we find that they may not scale, they don't really deliver the outcomes you were expecting. So being able to be very clear in terms of what is the problem I'm trying to solve. It sounds like motherhood and apple pie, but I find that a lot of times we miss it because we're so enamored by the new world that's emerging out there. So that's just, if I could just give one recommendation from years of having been burned doing POCs and test beds and pilots, it is define what you want to do at the end of your journey and then walk towards that.
That's great advice. That's great advice. I wanted to move on to our third topic, which is security at the edge. We've already covered it a bit in our discussion, but maybe, David, you can clarify for us maybe, what exactly needs to be protected when running AI apps at the edge, other than just the data sources themselves.
Yeah, there's a range of things. I mean, there's also a range of kinds of AI modeling and stuff that go on too, and some have different needs. Some are in there to protect it. So at a high level, you have kind of central AI. You also have federated AI as well. And people think, that'll help solve it because I'll just put the AI right at the device. So they do different degrees of helping. And I would say one, obviously, it's the data. Going in is one critical aspect that needs to be protected. So if central AI is feeding all the data in there, depending on the source of the data, much of it sometimes is personal information as well, especially medical information or financial stuff is personal information. From a federated perspective, there are either parameters going back, sometimes some data going back, but either case, in both situations, you've got to protect the model itself, the applications and the data and the models, the parameters. You impact those, you also impact the results. So it's not just the data, but even the model as it's running, you can change the outcome dramatically depending on what you do from those things. So I would say that's a critical area. And another one, not always thought about, but a lot of discussions on people on dealing with collaborative AI, meaning take as an example, looking at medical imaging across, and the more data you have in general, the more accurate your model is going to be. So if you have medical imaging and you're pulling in data from 10 different hospitals or 10 different research labs, the issue is not just protecting the data, but protecting everybody else from seeing the other person's data, because a lot of times this stuff is private and also very proprietary, but you want to get that benefit from it. So there, you need to kind of be able to protect that collaborative. You need to protect the model, and you need to protect even the privacy of the data that the people who are contributing to this can't see it. If you were going to do money laundering across in the banking industry, no one wants to share and see each other's information, but it's critical. But you could get a huge value out of doing that from that perspective. So those are at a high level are kind of the major things. You've got to look at the different AI models, and you've got to look at the different aspects of the data and the modeling and the parameters that are going back and forth, and make sure all of that is protected while it's actually running and while it's being passed back and forth.
Thanks, David. Ramya and Malini, any other security concerns that you think are important that haven't been mentioned or expand on?
For me, security, it's across the board. It's for your software, it's for your models, it's for your data. You can't let go of one and leave the others and stuff like that. Everything is part of the same picture. You need to protect data at rest, data in transit, and depending on the level of actors that you have involved, like when we say we're trying to test something, and then is it a nation state actor, means they have a lot of funds. And at that point, anything is game. They might even try and attack the processor, the cache in the processor. So you just have to up your game there.
Yeah. And the edge has its particular challenges because it's not in a secure data center in many cases. And they have their own unique challenges around that as well.
And to that point, I mean, what do we mean by a secure data center? There's a building, it has security guards outside, has locks and keys. But do you know how secure such a data center can be? They might even weigh you in as you go and weigh you as you come out. So you can't even have left a USB device over there. I mean, a little flash drive to suck in or suck out data, or if you've done it, you have to do it really fast. But that's what we mean about secure data centers. And it's impossible from a cost point to do that at a little box at the end of your driveway or, road type of thing. So a lot more goes on there to protect.
I think where there's a human, there's always a security issue, right? I mean, let's cover all the patches and everything that's systems related. You still can't prevent that one loophole. So it has to be inherent to your product design from day one. And then I think we talked about redundancy a bit. You always have to have a backup plan. But this is a race. It's a race, I think, that will never really have a finish line. We won't have one winner because we're constantly finding new paths to race on. So it's a hard one, David. I'm
just
glad,
like the viruses that keep changing their response.
Right. And it's the inside stuff as well, insiders, and not necessarily malicious. But a lot of a high percentage of security issues occur from accidental inside corruption. So you've got to be careful. It's not always malicious.
Right. And David, many edge computing locations, maybe this will be my final question, then we'll move on to Q&A, but as Malini mentioned, right, many edge computing locations are by definition not secure. They, just the amount of manpower and budget that you would need to actually make them fully secure would be very high. So they don't really have the benefit of being at the level of security that we would like. How do you protect the data and AI applications in such environments then?
Great question. And actually, I mean, it kind of feeds in a little bit to let me at least spend 2 minutes describing at least Hub's approach, because there are multiple approaches to doing this. A lot of things. I'll give you as one example what we're doing. We're effectively building kind of a secure data center in a box. Lack of words, we call it confidential computing, but it's a secure data center in a box. we literally started with probably what's one of the most secure computing devices out there are these hardware security modules, which are used for crypto devices. And we've kind of taken that and reinvented it and expanded it to include secure processing as well. So we put very powerful ways of actually doing processing, whether or not you're doing it on a standard CPU or you're processing it with high-end NVIDIA GPUs or even FPGAs, to another extreme. But the idea is we've taken that and put that all together and integrate into one platform. And the concept is you need to protect everything coming in, everything going out, everything at rest. But you also need to protect the entire environment when you're running at the same time. So you run everything in what we call these secure enclaves, which is really where the industry is heading a lot, is building these enclaves. We've just put these secure enclaves inside of its own kind of computing environment. So we have all the secure crypto services for encryption, for managing the keys in one place, accessing things. We've talked about access control on there. All of that is inside the same environment. So it's not a matter of outside. How do you make sure that that's not hackable either? Who's going in and saying, I have approval to change something in this environment? That has to be under really tight control. An insider wants to change it, they have to go through they might have to have 3 executives sign off on it. And it's a very secure process to be able to do that. So you need to add all of that into there as well. You need firewalls, embedded firewalls inside the thing. What messages are allowed in? What messages are allowed out? You need to control the entire environment from there. So you need to be able to have this thing perform, at all different levels. So that's essentially kind of where I say we're building kind of a secure, these secure enclaves, but we're putting it in an environment, a whole platform to kind of be like a secure data center in a box, because the idea is you really do have to drop it off somewhere. You don't know where it's going to be. And by the way, one critical piece is it is tamper resistant. If somebody picks this thing up, the second you try to do anything with it, shoot electromagnetic radiation at it, heat it up, whatever, the thing wipes itself out. So the concept is, yes, you can't go in, weigh everybody who's going in, measure them, make sure they have badges, biometric. But at least
it's like that Mission Impossible box. It'll catch fire and blow up.
We used to have it catch fire and burn up. We ran into resistance from data centers. Do not want anything in their data center that does catch fire and burn up.
Or in an airplane, or in California. Thank you.
We actually had to change the design a little bit and make sure, okay, look, just wipe itself out is actually sufficient. So that's actually what we have to do. So it's a means of it can hack into it. There's obviously a lot more detail around doing that. But the idea is, how do you provide literally a secure environment that you could drop in on the site that has all of those security mechanisms we talked about? And that's one approach that we're really looking at and working with a lot of people on implementing.
Great, thank you, David. And thank you both, Ramya and Malini, for your best insights and for a really wonderful discussion. These are all really relevant and fascinating topics that are related to emerging security challenges. So I'm glad that we got the time to cover them today. Right now, I'd like to take the opportunity to move into Q&A. If anyone in our audience has any questions for any of our panelists, you can drop them in the Q&A section below. And if you can't find that, you can use the chat box. That's okay. Just make sure to hit all panelists and attendees. And and we'll be answering them here and now. So we'll just give it a few minutes, and if we don't have too many questions coming in, we can just have a chance to do a bit more of an open discussion.
And some of these we've answered as we went along. I mean, personally, I learned a lot. I enjoy listening to both of you more than I enjoyed speaking.
Oh, let's see what it is. Okay. How is access control to secure enclaves implemented? This is a question from an attendee, Andy.
Access control and secure enclaves. Trying to think of what level to answer that question in a brief time. Essentially, how at least we're doing it is when you have the secure enclaves, we actually have a means of having multiple secure enclaves. And one of the secure enclaves is actually has all of the policies and all of the rules for what you're able to. So what roles do you have to access it? If you're making this change or you want to do this, do you need 3 people to sign off or 2 people? What's the time of day you could do certain things? So all the rules and policies that go into access control are actually inside a secure enclave as well, so you can't break into those. As far as uniquely identifying the individuals itself, realize inside the environment are all the crypto services. So all the keys, the master's certificate authority, all the ability to do signing is all there. So the access is actually controlled where the keys are sitting in an extremely secure environment as well. So we can very clearly authenticate the message and the individual coming in. So once we authenticate the individual come in, it runs in our secure access control environment, setting all of the, that sets any rules and policies that you need. And then depending on that, it goes ahead and lets you process. At the same time, since we also sometimes don't want people actually accessing the AI, it may also set the rules and policies for when certain things are actually permitted inside of the enclaves themselves to be able to do. So hopefully that at least gives you some idea. And if you want more, we could easily dive down in that later on.
I'd like to add to David's point, just like you have 2-factor authentication, even to access maybe your GitHub repository code, there's that level of authentication, like it is indeed David, and he is the rightful person, and he can update this model to this new facial recognition of who may enter this building, you know. A second part is in any cloud kind of environment, the keys to access these enclaves, the crypto keys, they might not be on that same physical machine. They will be in a key server, a key manager. So once David authenticates himself, then the key associated with that model, if we're talking about AI or some other software, is then handed off to that machine where this code will run. So that crypto entity, that enclave then opens up and can get active. So that was very essential for cloud use of secure enclaves. Before they were first thinking like, here's my secure enclave, here's this little thing that'll zap itself off if some unauthorized entry happens, but always the same software or the same model won't handle and drop on the same physical node. So we had to introduce this key manager with secure enclaves too, for cloud
and Malini,
use
what
cases.
we've done in our case, we don't trust anything outside the environment. So in the same environment is actually an extremely secure key management in a hardware secured environment. That's one thing we did in the platform is we keep the key management within the same secure environment as well.
But then you're thinking of a single box kind of everything tightly packed,
everything in one box. And we actually started with the security of the secure key management and extended it to include the securing and building home security mechanisms around the computing platform as well.
So how would you handle, David, if you had, we're talking about resiliency and maybe more than one box at the edge. How do you handle key exchange between multiple boxes for resiliency, for fault tolerance?
Yeah, so we can actually connect multiple boxes together. Actually, one box will be kind of a control point controlling it, because you also have to scale across First of all, inside the box, we could have up to 40 separate multi-tenant hardware secure enclaves inside of there. Multi-tenants inside one box, and then we would have we'll have a controller box that will actually let it scale amongst the other boxes as well. As far as the key management and sharing, it kind of depends. There are so many variations of what you want to do in that, but there is that flexibility. We can share keys in a couple of different ways. Looking out into the future, one of them is actually dealing with quantum key distribution to get to really the most secure way.
So today, what's your most popular? Today, what's your most popular way of sharing keys?
So in some way, we actually have a handheld, depending on the timing of it, we have a handheld mini HSM that's tamper-resistant design that we use for multiple reasons, to manage these boxes remotely if we need to. If people want, if it's the ultimate level of authentication So you could do multi-factor, multiple. This is hardware-based mini HSM level of authentication. You can actually use that if you need to securely transport keys from one place to the other if you need to. So there are multiple ways of doing this. We may also process the crypto in one box, and we have means of doing very secure channel into other boxes as well. Because we have a hardware firewall, we know precisely what is actually going to be passed from one place to the other. So it's a longer discussion because there are actually multiple ways that we can do that. And in some cases, we're finding
David,
people manually with the handheld is fine, but when you want to scale and do it automatically, then we'll use a different way.
Does Hub Security have maybe some white paper that you want to share with the audience who's interested in learning more?
Sure, absolutely. First of all, we will send it out. It may even be online, and I'll check. And if not, and no matter how much detail, for those who want to dive deeper, we'll set up a separate session. Malini, we certainly can get offline and go through in more detail, because no matter how much we write down in there, it's never sufficient.
Yeah, and it's also evolving.
Yes, and it's
coming back to
changing.
Ramya's point, it might be a POC and it has some flaws and we have to improve upon it and doesn't scale it. Hey, neither was Kubernetes born on day one. It's been evolving.
Yes.
Neither has Intel architecture all been defined on day one. Everything evolves and improves. And
we're using Kubernetes to help scale in one way.
Great. Well,
Annie, I hope we answered your question. Thank you for the question.
Oh.
Yeah, and thank you everyone for joining us today. Thank you to our speakers, David Hochhauser and Malini Bhandaru, Ramya, Ravichandar. We hope that you're all staying safe and healthy at home, at the workplace, wherever you are. And we look forward to hosting
I'm
many
out there
more
in
discussions.
Mars. I'm safe.
I don't know. Jeff Bezos is on his way. You may not be.
No, he's going to be kind of just high up in the orbit, not traveling for another planet.
That's what they always
Thank
say.
you, everyone.
Take care.
Thanks. Thank you.
Oh, wait, before we jump off, I just wanted to tell the audience that to get in touch with today's speakers, feel free to reach out to them directly. All today's attendees will be receiving an email in the coming days with contact information to the panelists of today's discussion, so don't be afraid to reach out to them and drop them a line if you have any further questions on any of today's topics. And to stay up to date on upcoming webinars from Hub Security, you can follow us on LinkedIn, on Twitter. I even have we have a Medium where we release top stories weekly. So feel free to stay in touch with our panelists and also to stay in touch with Hub Security for some future webinars and interesting discussions. Thank you again, and take care.